Hello, my name is Darren Thomas. I'm the Director of Educational Research Techniques.com. In this lesson, we're going to continue with Unit 1, and we're going to continue also checking the different normality rules that we have to deal with for regression analysis. So why don't we go ahead and go over to RStudio. So you can see right here I'm inside RStudio, and what we're going to do now is we're actually going to run our model that we want to use for our purposes, and we want to see if our model meets different assumptions of different assumptions of a regression model. Excuse me, that's what I meant to say. And so what's going to happen here is that, like I told you, we're going to run the model, and then we're going to look at some plots that R is able to make for the model. So here in lines 1 and 2, I just have the various packages we've been using for this particular unit in the book. And now in line 4 is where I actually run my model. So what I want to do here is that I'm going to make a model called salary underscore model. That's the name of the model. And I'm going to use the LM function. The LM function is what you use to make a regression model. And we want to take the log of the salary, because remember we transformed it. And we're going to use hits, home runs, walks, log of the years, how long they've been in the league. Whether in the American League or the National League, that's a categorical variable, if you will. And we're going to use all these things right here. These are all the independent variables: hits, home runs, walks, log years, and league that they're in to predict salary. And the data set that we're going to use is completed data. We made this with the mice package where we replaced the missing values with some sort of a value that we calculated using the mice package. So having said that, we're going to go ahead and highlight this, press Control Enter, and run it. Now, in line 6, we're going to actually take a look at the plots that R will make for you so that you can assess the assumptions for your regression model. So in line 6, I've used plot, and I put the name of my model, salary underscore model, and I press Control Enter. Now, when it does that, you can see this little printout right here, hit return to see the next plot. So I go down here and I press Enter. Now, the first plot that you can see here is let me make it a little bit bigger for you, is the residual versus fitted. This should show some sort of a even dispersion of the data, because it indicates a linear relationship. You don't want to see any particular patterns. Now, I mean, it depends on your opinion. It's kind of fanning out a little bit, so there might be a problem here. And then for the actual numbers that you can see, these are indicators of extreme outliers that you might want to take a look at removing, because they're really, really far. And the criteria for how far away are is whether they're beyond the number 2 here. So you can see, I know this is very small, but there's a number 296. That's probably row number 296 in the data, row 218. And there are definitely 2 standard deviations above the mean. This guy down here, 283, I know that's hard to see. He's, 2 standard deviations below the mean there, which the mean is 0 in this case. And so right now it looks like the residual plots are okay. We're going to come back to this when we can actually do a statistical test for this, but I can't deal with that right now. So here we go. The next one is the normal QQ plot. It shows you how well the model is at predicting things. And so you want to see most of the data points on the line here. So as you can see, it does pretty good. There are some extremes, 296, 218, 283. By the way, these were the 3 numbers that were a problem in the previous plot. So that just shows you how there's a relationship between them. So, but generally the model's doing a pretty good job. For extremely high values and extremely low values, it's not so good. And then I believe we're almost done here. The scale location plot helps you to find outliers. And so I'm sorry, this is a test for homoscedasticity, which is very, very important for checking the appropriateness of the model. And so you can see here that again, the data is mostly spread out, which means homoscedasticity is not a problem. And then the last one is the residual versus leverage plot. Now this is the one that helps you to find outliers. Again, the same 3 people are causing problems. 283 down at the bottom, 296 here, and 218. So we might want to remove those. Now, there was something I wanted to show you. Let's go back a few slides here. The residual versus fitted. Now, again, this looks okay. It looks like there might be a little bit of a fan, but there's a way to test this to confirm if everything is okay. And that is with the BP test, which I believe is from the LM test package. So this is line 7 in our code right here. if you press Control Enter, it'll run it, and it'll help you to test if this is really okay or not. And so what you want is you want your p-value to be greater than 0.05 if that's your cutoff. So you can see here that yes, the residual versus fitted is okay based on the analysis of the Bruschi-Pagan test. That's a test that you can run to assess whether or not your model is having problems with linearity or homoscedasticity, if you will, which is a common test for regression analysis. So this was a very simple video. We just looked at several plots to figure out if our model was meeting some of the assumptions of a regression analysis. So the residual versus fitted kind of gives you an idea of the linearity, if the model is linear. If there's any kind of a pattern here, you have a problem. In the next one, we looked at the normal QQ plot. This, again, is kind of showing you how well your model does at fitting the different values. You want most of your values to be on the line. Again, after that, the scale location. This is for homoscedasticity. You want to make sure that there's a nice spread, that there's no pattern in the data. Otherwise, there might be problems. And lastly, the residual versus leverage plot, which helps you to find outliers and problem ones that are really having a strong influence on the line. So these are useful tools for you as you do your own regression analysis. So I hope that this was useful for you as you continue through our journey here in this chapter on understanding regression. My name is Darren Thomas. I'm the Director of Educational Research Techniques. Take care.